So I'm in the laboratory the other day, and I'm running a very interesting analytical procedure on the ICP-MS, which detects heavy metals down to parts per billion concentrations. And I ran across something that's really fascinating. I want to share it with you, and then I'm going to shoot a video on this too, because it's going to blow your mind. But let me make sure that everybody understands the difference between atoms and molecules. So, you know, the table of elements shows the elements. These are atoms. These are individual atoms that usually in nature, they do not exist by themselves. They form together to make molecules or compounds or sometimes polyatomic ions. But the instrument that I have, the ICP-MS, counts individual atoms. Like it can actually count one atom of lead hitting the detector, and you'll see that. Like literally, it can count one. When I'm looking at the screen and I'm running some liquids, I'm looking at the lead counts, and they could be, 10 per second, literally 10 atoms of lead per second, or they could be 10 million. This thing has a 9 orders of magnitude range in detection, which is pretty freaking wild. So anyway, I'm in the lab, and I'm testing some things, and I've got a glass jar. Well, I guess it's more like a beaker. And then I've got a polystyrene beaker, and I'm trying to compare the background noise that's found in water that is held in a polystyrene beaker versus a glass beaker. Now, most of you think that glass is a solid, and you're wrong. Glass is not a solid. Glass is a liquid with a very, very slow flow rate. It's flowing. In fact, if you look at glass windows that are a couple hundred years old, they're thicker at the bottom than they are at the top because they've been flowing down. And I'm not making this up. I guess you can go verify it for yourself. Find an old cathedral with some stained glass windows, and you'll see what I mean. Anyway, so glass is not even a solid, really. It's a liquid. And I was wondering how much contamination goes into this water if you put it in a beaker of glass. So I'm running this instrument, the ICP-MS, and I take the intake tubing and I stick it in a beaker full of water. And this is lab-grade water. It's called DI or deionized water, 18.2 mega ohms of resistance. Basically, we purify water so much that it becomes an insulator. Did you know water's an insulator? See, a lot of people don't even know that either. People think water conducts electricity. No, it doesn't. Water conducts no electricity. Water is an insulator. The only thing that conducts electricity in water is the minerals that you add to it, which is not water. That's mineralization in the water. That's what conducts the electricity. So pure water is an insulator. And so we produce highly insulative water, which is called trace grade laboratory water, 18.2 mega ohms of resistance. And some of you who are electricians, you know that's an insulator, right? So that's the water that we use. Anyway, we put this water in a polystyrene beaker, and then I put more water in the glass beaker. Now, so I have the uptake tubing in the polystyrene beaker, and I'm reading the lead counts. I'm reading the number of atoms of lead that are hitting the detector on this instrument. And this is in full-on go mode. And it's counting away, and I'm seeing something like, 10 counts a second, something maybe 5 to 10. Very, very low. Pretty much no lead. 5 to 10 atoms a second is almost nothing. As close to zero as you're going to get. You can have five counts a second just from air, just in the air. So then I take this out and I put it in the glass beaker where we have water in the glass, and I'm looking at the lead numbers, and they skyrocket. They skyrocket to something like 800 counts per second. And I had a double take on that. I was making sure I'm looking at the lead mass here, which in this case is 206. It's one of the isotopes of lead. Lead has several different isotopes, but I look at 206, 207, and 208 in terms of atomic mass units. And I'm seeing this spike up to 800. I'm like, wait a second. In a glass beaker, the water is eating so much lead out of the glass that the number jumps up to 800. So I put it back in the polystyrene beaker, and the number went back down to 5 or 10. I'm like, holy crap, sure enough. So I poured out the water in both beakers, and I got fresh water again because I just wanted to make sure that I wasn't screwing something up here. So I got fresh water, DI water, once again, perfectly clean water as an insulator, put it in the water, the glass beaker and the polystyrene beaker again, and then I put the uptake tubing in the glass beaker. Sure enough, it's back to 800. The water is eating the glass. Now you might wonder, well, what's the pH of this water? Is it acidic? No, it's not. It's pretty much neutral. I don't know. It's around 7.0, something like that. It's neutral water. I mean, that's my guess. I haven't actually measured the pH, but I know it's not acidic. I drink this water, okay? It's not acidic. I'm guessing it's 7.0 or maybe it's 6.5. Anyway, it's not strongly acidic, not at all. But there's so much, the glass is being eaten by the water, and there's so much lead as an impurity in glass that I was able to see 800 atoms per second on this instrument in the water just from swirling it around in a glass beaker. Now, what is the upshot of this? The upshot is, if you buy anything in glass, I know what you're going to say. You're going to say, wait a minute, you've been telling us don't buy anything in plastic, and that glass is better. And that's true, glass is better, but I'm telling you, anything that you have that's in glass, you're eating lead. A very, very small amount. Don't be alarmed. I'm not saying that this is not a safety hazard. I just want to be clear. This is more of a scientific curiosity. 800 atoms of lead is not going to make any difference in your biology. Believe me. Not when you're eating, trillions and trillions and trillions of atoms of calcium or whatever. A little bit of lead at that small is negligible. I'm just saying that if you are eating something in glass or drinking out of glass, you are eating and drinking lead. And you didn't even know it. I didn't even realize this. And by the way, lead isn't the only thing that's in the glass. I didn't bother looking for the other elements, but I'm certain that we're going to find some other crazy things in there if we look hard enough, because glass is not, it's not a super pure material. It's made with raw materials that have a huge assortment of various elements in them. There's probably some cadmium in there, probably some nickel in there, probably some copper in there, manganese, molybdenum. I mean, who knows what else? So you're eating lead in your peanut butter jar without even knowing it. But again, this is not a health concern, so don't be alarmed. The levels are so low, but yet the instrument that I use in the lab is so sensitive that it can pick up 800 counts per second, 800 atoms of lead, essentially, per second. Wow, that's sensitive. If you drop a flea into this water, it will change the elemental composition so much that the instrument will be able to pick that up. If you have a drop of saliva in the whole beaker, the machine will pick up the difference. It will pick up the magnesium and the sodium and all these other things. It is so sensitive that it can actually pull out the numbers of lead in glass dissolved by water. That's pretty wild. In any case, just more adventures in science at the Natural News Forensic Food Lab, discovering what's in the stuff all around us. Bottom line is, you're totally safe to drink out of glass. I've been drinking smoothies in glass for over a decade, and I'm going to continue to do so. But you can also drink out of stainless steel, which is fine. But did you know stainless steel contains some amount of chromium and some amount of nickel, as well as the iron, obviously, and lots of carbon. But you're going to get a little bit of chromium from that. A little bit. Not too much, but it's in there. So there's nothing that's totally inert, just so you know. molecules are interchanging all the time with everything you touch, everything you drink out of, everything, especially if you start microwaving these things, then you're going to get a lot of lead coming out of the glass. Hey, I should do that. Okay, yeah. That's going to be, all right, I'm going to take a microwave into the lab, get the video camera set up. I'm going to try this experiment, just like room temperature water, and then I'm going to microwave water in a glass jar and see how much lead comes out of that. How's that sound? That's going to be fun. I'm going to make a note of that, get that done. Watch for that on naturalnews.com. Just one of many experiments we'll be conducting in the lab. Can't wait to see how that one turns out. Should be fascinating. All right, take care, everybody. Click subscribe to stay plugged in to the Health Ranger Report.